Hello and welcome to Into the Terminal. I'm your host, Scott McBrien, and joining me as always is Nate Lager. Nate, today we're going to go more into our packaging story arc and talk about managing pods of containers. So last week we talked about just operationalizing containers. Now we're going to take it a step further and operationalize groups or pods of containers.
Yep. So let's get into the terminal and I'll show you what a pod is real quick, and then we'll talk a little more about what a pod really is and why you might care about it. So first of all, we're going to make a pod. I'm going to stick with the copy and paste today because there's a lot of complicated commands, and we'll get into that. But all right, so Podman pod create, pretty straightforward. We're making a pod. -P80:80. That should look pretty familiar from all of the containers we've created so far. The way networking and port forwarding works changes a bit when you're dealing with pods. And again, we'll talk about that a little more later, but you have to open at the pod level, not at the container level. Okay. And then we're going to give it a name, and we're going to give it the super creative lamp stack name because, well, we're going to deploy a lamp stack. And, what else would you call it? I could call it Joe, I guess. Next time I'll call my pod Joe.
So,
All right,
Nate, real
now.
quick,
Yep.
what does LAMP stand for someone who may not have seen that before?
Linux, Apache, MySQL, PHP. This was a really common term used like when that was the standard for all of your web applications. That's obviously changed a lot. There's other acronyms now for other things, but I'm old school. I wrote in PHP. We're doing PHP today. All right, so the next thing we need is stuff in the pod, because the pod itself here, if we do like a podman, I'm going off script already, PS, you're going to see, oh, maybe not, podman pod PS, you're going to see a pod with nothing in it. When we put something in it, you'll see there's an additional container running that is the pod, and I'll show you that in a minute. So let's put a thing in our pod. See if it's still on my clipboard. All right. We're going to podman run. We're going to put it in the background with -D. We're going to tell it what pod to put it in. Let me see if I can get this highlight away so you can read better. What pod to put it in. That's our lamp stack pod. And we're going to pass some environment variables in. I forget if we talked about this before, but you can pass variables in or environment in to your container so that you can then read it from the application running in the container, right? So -E mysql user DB user tells MariaDB that's running inside of this container that's the user I want it to create, right? So this way we don't end up with just a MariaDB running with no database and no user and whatever, right? So all these environment variables will get passed in, and that's what's going to get created. We're going to call it DB because it's a database, right? And we're going to use the RHEL9/MariaDB105 image. Now this comes from the Red Hat Container Registry. These are not the free UBI containers. This is an official RHEL container. You do have to authenticate to this registry. I've already done that for the sake of time, but just know that if you're going to use these containers, you have to authenticate. And Scott's raising his hand. What's up, Scott?
Yeah, I just want to point out, yes, these are not freely available like the UBI containers where you can just like pull them down off the registry. However, if you have a costless RHEL or Red Hat developer for individual subscription, that is enough to get you to these RHEL containers as well. So
right.
Yeah, we're using something that's not just open to everyone's use,
Right.
but it is open to any subscriber, including those who have a free subscription.
Free might have been the wrong word to use, as in not free. They require a subscription. Good clarification. Thank you, Scott. Okay. All right, so we're going to hit enter, and this is going to stand up a empty database inside of MariaDB, inside of a container, inside of our pod. So now if I did a podman PS, we should see MariaDB running. I guess it hides the container pod. It used to show a container for the pod. It's not doing that anymore. All right, but if I did a pod PS, now we'll see my lamp stack pod has two containers running inside of it. See it here? The two containers, one of them is the infrastructure pod, and the other is the MariaDB container that I just created. Now, I also want to put something in my database. Otherwise, the database is kind of boring, right? So I have a little command here. I'm going to paste in here. Now, this is getting into some more advanced Podman stuff. We're going to run Podman exec. Exec tells it run a thing in the container, right? We're going to do -I, which means that it'll accept input. It's interactive, right? We're going to tell it what container to do. That's this DB, right? And this is the command we're going to have it run. MySQL -u dbuser -p Red Hat, because these are the username and password that I gave it when I stood up the container. What database to run? Like this, everything after here is standard MySQL command line stuff. And then we're going to redirect database.sql, which is a database dump that I created for the sake of this demo. And what they should do, cross your fingers, is it should execute that command, even though database.sql is on my server, not in the container, right? It'll still redirect that output. So here we go. And there's no output, but that's a good thing. That means it worked, right? If I did another Podman exec and did like a select star, it would show you the content of the database. But this is the critical path, and I don't want to do that right now for the sake of time. If you guys want to see that later, we can. But for the moment, what we're going to do next is we're going to stand up the Apache container, okay? Now, let me get the highlight off again. Podman run -d to put it in the background. And again, we're passing in these environment variables, right? We're telling it the host. We're going to talk a little bit about that. This has to do with that networking I talked about. The host is DB. That's the name of the container. That's the name of the container we put the database in, if you remember, right? It knows that within the pod. It has this DNS resolution that it says DB points to this other container. Then, of course, we have the user, we have the password, we have the database, testDB, right? And then the name of the pod we want to put it in, lamp stack, and we're passing in a volume root www to var www.html. This is again, this is a static volume, or a persistent volume that I want to pass in that contains an index.php file that I wrote, which will do a database query, so we can actually show you that this thing is talking to the database inside. And it's using the PHP SQL container that I made, right? It's a thing that I cooked up just for the sake of this demo. It's a local container that's on this machine. All right, and it gives us the very friendly ID here that tells us that it did a thing. If I do PS again, now it is showing us the infrastructure container. I don't know why it didn't before. Anyway, you can see now we've got PHP SQL running. We've got MariaDB running. This is our infrastructure container. And you can see they all say they're listening on the same port. Now we know two containers on the same host can't listen on the same port. That's because it's all managed by the pod, right? You also notice I did not tell it to listen on the MariaDB port 3306, only the web port, right? That means that that's accessible outside of the pod, whereas the database is not accessible from outside of the pod. So now we're just going to use curl to show you that this should work, right? All right, so this is essentially what my index PHP does. It reads the database. These are 3 rows that are in my table, and it's just outputting the data from them. I can show you the PHP if you really wanted to see it, but that's essentially what we're doing here. So my web app is able to talk to the database, even though from the host outside, I can't talk to the database. And that's our critical path for today. So I guess we can move along, right?
Yeah, so stay with us after the transition, which is where we take questions to the audience. By the way, Nate, Shantanu already has a question for you.
Oh, good.
And we could talk more about managing this pod of systems from beyond just building it to how do we actually recreate it and manage it over time. So we will do that after the transition. See you in a moment.
See you on the other side.
All right. Hey, Nate, how's it going?
Good. I feel like I just spit a whole bunch of information out at everybody. I hope I didn't lose anybody.
Yeah, well, I think what we may need to do is like talk about some of the different types of containers that we interact with.
Right.
I think that might be like yet another story arc that we can spend some time on, because like there's a lot of MariaDB stuff there, and if you're not familiar with databases, like that might be interesting to learn or know.
Yeah. So that ability to pass in variables, environment into the container is key when you're deploying applications, right? Because we're used to sometimes manually setting some of this stuff up, right? Like you could imagine you're a database or you're a sysadmin, right? You deployed MariaDB for your database guy to do his thing. You might deploy it manually, set the usernames and passwords manually. Maybe you do it with automation or whatever. But this ability to pass in the variables just says make a container and this is the state I want it to be in, and that's really handy.
So before we transitioned, you had put in a SQL database copy, right? That you
The
had
dump file,
backed
yeah.
up. Yes. And so Shantanu had asked about what that looks like. And in fact, I can show the audience if my producer skills are not on par with producer Eric's.
Find the thing, click the button.
I'm clicking the button.
There we go.
Also, since producer Eric is not here, there's no one for us to make fun of people's hair today. So
I know.
makes it sad.
I know. All right, so if you want to put my terminal back up, I know that's more asked for you, but I can show you the file. So right here in root's home directory, there's this database.sql file. Right now, this is a text file. There's a tool called mysql dump, which you can run if you give it a username and a password in a database, and then you can redirect it to a file. It just basically dumps the schema, the table definitions, and the data all out to a text file. And this is what it looks like. Now, there's a bunch of comments. That's what these /* things are. And this is just kind of metadata and whatnot that goes along with things. But let's see here. Here we go. It's creating my table 1. It's telling it that there's an ID field, there's a data field, right? And there's a primary key and auto increment, that kind of stuff. So that if I put more data in, it gives it. And here's the data that it's putting in. Again, this is hard to read because it just puts it all in one line. Because it doesn't have to be easy to read. It's a text file that's parsed by the MariaDB or MySQL engine, right? So insert into the table, and there you go. You see it's got the ID. This is my data. That's exactly what you saw in the PHP example when it executed it and ran it.
And
so that's essentially what this is.
And you had said that we could do a Podman exec to do like a select star and print that out from our running database as well.
Yeah, let me clear this so you can see better. Let's see. Podman. Now we're going off script here. Podman exec.
We are.
Let's see. We're going to do IT this time because this is going to be an interactive that I'm going to actually type in with a terminal. The name of the database, or the name of the database container, right? And then we're just going to do mysql -u. What did I call my user? DB user -p Red Hat, and then the name of the database, which was testdb, I think. And it should put us right there. You go, MariaDB prompt, testdb. This is the same tool you would use if you had a physical, like full-on MariaDB or MySQL database server, right? So if I did a show tables, we've got, there you go, table 1. Select star from table 1, not tables 1, table 1, and there's the data. Same thing with the IDs. If I were to add another one in here, table 1, let's see. I think it's like values. No, I forgot my SQL syntax. This is going to end badly.
But that's fine. I think the biggest thing was like, we did a thing and we were like, look, it worked. But there was no like output or verification that anything had changed. I think that's what Shantanu was showing. And I think we covered it here, right? We showed you what that was in the SQL dump file. And then we showed you what was in the container after we had uploaded that SQL dump file.
Cool. Right.
All right. So Nate, you also want to talk about or go into a little bit more depth on ports exposed to the outside versus ports available inside the pod.
Yeah. So trying to think of the best way to show this in the terminal. Maybe we'll just talk about it. But basically, when you define a pod, picture a pod like a container of containers. Okay, so you make a pod and then you put containers within that pod. That's exactly what it is, right? Within the pod, there is networking, right? Now you can define networks in Podman as well, just like you could with Docker. But I think a pod is a little more straightforward because it makes this sort of isolated environment almost where your containers run. You could have a dozen containers in there that are all talking to each other. Maybe there's API endpoints in there. Maybe there's databases in there. Maybe there's other services that things have to talk to. And then you expose just the port that the application needs to expose to the user, right? So if you've got a dozen things in there, they're all listening on different ports. Within the pod, they can all talk to each other. Outside of the pod, only the port that you've mapped gets mapped. And it's weird, right? It gets mapped to whatever container is listening on that port, right? So notice I didn't say what container to pass 80 to. I just said pass in 80. So it saw, oh, there's an Apache container in here. It's listening on 80 because it's defined that way, that it listens on port 80. It just says, okay, whatever's coming in on 80 goes to that container. If I had mapped 3306 in, then it would map anything that goes to 3306 to the MariaDB container because it listens on 3306. It does get a little confusing if you have more than one container inside of there that runs on the same port. I don't really know how it makes that decision. It could be used maybe for like a load balancing situation. I've never tried to do it that way, but that's just a thing you want to be aware of. If you have more than one container in there that's listening on the same ports, that could cause some confusion with that port mapping.
And so the ultimate result is that we're exposing a port to the outside world. That when traffic gets passed in, it goes into our to the right container. And when we have applications running on that container that are using other services from other containers in the pod, they're able to consume it.
Right.
But we don't have to expose their ports to the outside world.
Right. This is sort of like another layer in your defense in depth strategy, right? Imagine that instead of a pod, this was a network, right? And the users need access to the website. They don't need access to your database. So your firewall blocks off, the database access, but it allows the web access, right? Same concept. Now, we could go deep on like, oh, what if somebody breaks out of your web container? Then sure, they're now effectively on the same network as your database. But this is a very simple example, right? Most people aren't running databases right next to their web application anymore. They have a separate service that houses all of their data, right?
Well, and also when we think about containers, right, the whole reason that we do it is to make it portable. We talked in a previous episode about doing things rootlessly. So if something were to be exploited, they're given access to content that the non-privileged user is given access to. So, when you're designing that container and thinking about what you're putting into it, if people were to misbehave or there was a bug in some code that allowed someone to consume data that was unintentional, they can only do so from within their container or within the rights of their user that's being executed with.
Right. So this is another layer of sort of abstraction there, right? Or another layer of security, where if you do naughty things in the container, you're limited to what the container can do. And then if you get out of the container, you're limited what the user running the container can do. Now, again, with our examples here, we're running as root, but that's just because the lab environment makes it easier to run as root. But you can do all of this as a standard user.
Yeah, and I think Shantanu is asking for a clarification. So inside the pod, we are running multiple services that are accessing or have exposed multiple ports. But when Nate designed the pod, and Nate, maybe bring up the command where we assign the port that's being exposed to the pod.
So if we do the Podman PS, you can see that, right? Or do you want to see when
I was
made
thinking
the
about
pod?
the create.
Let me go back. We'll just copy and
paste
history. Here, okay. There you go.
There we go. So what Nate was doing when he created this was we will expose to the outside world port 80.
Right.
And port 80 traffic will be passed to a container inside the pod who is also listening on port 80.
Right.
Even if there are other containers inside that pod which have open ports, like our MariaDB container, because they're not listening on port 80, people from the outside world can't directly access them.
Right. Right.
But applications within the pod do have access to whatever other services are there inside of their constrained environment.
Right. All right. Any other questions about pods before we move on? Because the next part I think is fun.
So the next part is how do we recreate this thing, right?
Right. So we put a bunch of commands in there. You could obviously do that, script that, whatever you want. But there is a better way, and we're going to talk about that in a moment. So on last week's show, we showed about how you could use Podman generate to generate a systemd unit file, so you could run your containers through systemd. Now you can do that for pods too, but that's not what I'm going to show you right now. We're going to clear the screen. There's another Podman generate command that does Kubernetes YAML definitions, right? So Podman generate kube lamp stack. We give it the name of the pod. And what that's going to, and I'm redirecting it to a file. I'll show you the contents of the file in a second. But what this does is it takes that whole pod definition and it puts it, yes, there's a bunch of warnings. It's all about the IDs being longer than Kubernetes can accept. But what we're going to do now is open up the YAML file. And inside of here, it's got everything we need to recreate the pod. All right, so we've got the kind is a pod, some annotations, which I think Kubernetes cares about. And we've got some labels here. This app and name are what the pod is going to be named when we create it. Okay. And there's another thing to think about, and I'll show you this as because we're going to recreate the pod in a moment using the same YAML file. But so we're going to change the name of the pod because we've already got a pod called LampStack. We'll call it like LampStack 2, maybe. I don't know, because I'm really creative. Here we go. Is the container definitions themselves, right? So this is the spec for what's in the pod. Containers. This is, if you were to do like a Podman inspect, which is a way to get information out of your container, this is the kind of data you're going to find in that, that inspection, right? It's also the data that we passed in on the command line. Remember I did those environment variables, MySQL password, MySQL database, MySQL user. Those are all right here. If I wanted to change those, I could change them here. There's also a way that you can take a mapping file and also include that when you rerun this. So you could take all of these variables and put them into a separate mapping file. It's a little more advanced than I wanted to go into today, but just be aware that that's a thing you can do so that these passwords and usernames aren't repeated or even stored inside of this YAML file. Obviously, they'd be stored in the other file, but still, my point is, you'll see when we get down to where we're defining the web container that we redo all of the same ones, right? So if I wanted to change that username, I have to change it in 2 places, whereas if I mapped it in with this other file, I would only have to change it in 1 place. But again, not going into that today. Right, and it tells us what image to use from MariaDB, right? And what name we want to use. Now, a thing to note is when we deploy this Kubernetes file, which I'll show you in a minute, it takes these names and appends the name of the application or the name of the pod at the beginning of it. So it'll make a pod called LampStack2, and all the containers inside of it will be called things like LampStack2 - container name. So in this case, LampStack2 - DB. So remember we had that case where the web application, the database host that I was passing in was the name of the other container. You need to be aware of that when you're defining these files, because that container name isn't going to be DB anymore. It's going to be LampStack2 - DB. Okay, now I know that might sound confusing, but basically you take the name of the pod, the name of the app that's defined further up here, right? When I showed you that up here, when we changed it from LampStack to LampStack2, the app and the name. And if you're referencing other containers, they need to have LampStack2 - right? If you're referencing them in the data or in the as DNS names, you need to include the name of the pod there. I feel like I'm rambling here, but this is important because if you don't do that, it's not going to work. All right, and then of course the name of the image, the name of the container. We went over that. And then at the bottom here, another thing I want to point out, that volume we passed in to the web container, right? Remember we sent root www into var www HTML. Well, that's been translated into Kubernetes speak here. It makes a volume and it mounts that volume to a container, right? So you can see here we've got mount path var www HTML. It's got a name for it, and it's got down here the host path or root www. It's a directory, and it gives it the same name that we then map up here further, right? So there's also more dynamic ways to do static volumes, like you can map them to an NFS share, for example, and that makes it so that if you deployed this on separate machines that were all on the same network that could get to the same NFS share, then they would all reference the same thing, right? All right, so that's the definition file.
So Nate, now that you made this Kubernetes YAML,
Yep.
you have to OpenShift, right? You have to use a Kubernetes instance?
No, you can deploy it right here in Podman. Now, you could deploy it to a Kubernetes-backed orchestration platform, OpenShift or Kubernetes or whatever else, right? Again, this is RHEL Presents, not OpenShift Presents, or not. This isn't RHEL Presents. This is Into the Terminal where we talk about RHEL, not where we talk about OpenShift. So there you go, Eric. I plugged your show. What we're going to do is first, remember, we can't have two pods listening on the same port. I can show you quick in that YAML file. Where is it? Here it is. That we map port 80 still. I could even change it, I suppose. There we go. Container port and host port. This is the exact same mapping we did before. Container port, this is what we're mapping to inside of the container, and host port is what we map to on the host. So if we did this on port 81, right, now it'll listen on port 81. The reason I did that is still have the other pod running, Podman Pod PS, and that's still listening on port 80. So if I defined another one listening on port 80, it would give me an error, and I didn't want to mess that up. So if we do a Podman play, which is just like you're replaying a thing, kube, because it's a Kubernetes file, and then we take the name of that file that I did, lampstack-pod.yaml. What should happen here is it'll define a new pod using the same containers, using the same definitions and whatnot, and it'll put it on port 81. Cross your fingers. All right, so now if we do a podman, pod, PS, again, we should have two pods. There we go, lampstack and lampstack 2. We don't have any data in there yet, so let me get back to my command here where we brought in the database for this, oh, here, let me show you. Do a podman PS now. This gets a little cumbersome now, but you can see the container names are now, like I was talking about, lampstack 2-Apache, lampstack 2-DB. Now, if I take my, here it is, my command from earlier where we put the database file back in, let's paste it in. Let's change that container name from DB to lampstack 2-DB. Now we're going to import the same database dump into the new database. And I think there's ways to do this automatically when you stand up these containers. I just didn't dig that deeply in. Now we should be able to. Did Nate break anything yet? No, I didn't break anything. I even went off script and didn't break anything. Now if we do, let me clear the screen and we'll do that curl command from earlier. Remember port 81 is where we put the new one. This should get us the same data from before because we imported the same database file. So you can see, right? Podman PS, no, pod PS. It was that easy to redeploy. Now, if I wanted to deploy it again, change the name, deploy it again, or go to a new machine and deploy it again using that same YAML file. So this takes all of that, all those commands we had to run at the beginning to get this thing developed, get this thing deployed, and puts it into a nice repeatable file, sort of like we did earlier when we compared the container file to the manual commands that Scott was running with build it. Builda? Not
Builda.
Builda. Yeah, Builda. So, again, I just spewed a bunch of information at you. Do we have any questions?
No, I think that everyone was following along except waiting for it to blow up on you, which, man.
Or they're all
you-
lost? Did I lose anybody?
Uh, so we are at the end of our time together.
We are right on
any
time. Look at that.
words, Nate?
Any final words? I'll just say that this is exactly how I deploy my own websites. Right. I run a host on a cloud provider. It runs Podman on top of I think it's CentOS, just because the CentOS stream, because that's what was available from the cloud provider. I run Podman. I run Kubernetes YAML files the same way as I just described here. So, like, if I want to deploy a new WordPress or something, that's exactly what I do. I have it all put inside of a YAML file. I just make a copy of it, change the names around, and deploy a new one. I can get a new site stood up in minutes. It's really nice. It's really handy.
Excellent. So coming up next week, we're actually going to take a week off because we needed a break. So a week
Too
after
much
that,
Podman.
yeah. Well, we're going to be man, because week after that, we're going to talk about troubleshooting containers,
Yeah.
and I think that's probably going to close out our packaging arc. So that'll be in 2 weeks. And then our next RHEL Presents with Eric is going to be getting certified on RHEL, where he's going to talk with a guest about Red Hat certifications, like personal certifications. So like Red Hat Certified System Administrator. Wow, that's hard to get out. Or Red Hat Certified Engineer. So keep those in your thoughts. And then
Yep.
also Eric is kicking off a mini series on modernizing systems management using Red Hat Insights. So he has a special guest of Mr. John Spinks, who is like the us, but for insights.
Yeah.
And they'll be talking about some of the tools with Red Hat Insights and how you can use this service that is included in every Red Hat Enterprise Linux subscription to do systems management and get information out of your machines and do compliance stuff. Like there's a lot there. And I know that we've touched on it a couple small times here Into the Terminal, but they're doing I believe a 9-episode story arc on this mini series. So there's
there. So if you want to know anything about Insights, tune in.
All right. Until 2 weeks from now, happy Into the Terminaling.
Yeah, absolutely. Have a great one.